Okay guys, so lesson 4, it's the last lesson of operations on functions. And well, we'll do compositions tomorrow, but this one will be on the quotient of two functions. In other words, we're dividing two functions. So similar to what we've done before, we're going to look at two graphs. This one, the parabola is f of x, and the straight line is g of x. We're going to look at the x-coordinates, and from those x-coordinates, we're going to figure out what the y-coordinates of each function are. That's for f of x and g of x. And then once we have those, we'll be able to divide them and then graph the new function. Okay, so for x equals 3, we're just going to go to the graph and we're going to locate where does x equal 3, 1, 2, 3. And we're going to go up to f of x, and we line 3 up, we're at y is equal to 6. Okay, so f of x, y is 6. And on g of x, the straight line, we line it up with the y-axis, we're at 1. Okay, now we're going to go to x equals 2. So go over 1, 2. Where's f of x and g of x? What are the y-coordinates on those graphs? We're at 0. So both are 0 for x equals 2. At x equals 1, it kind of switched which one's above and which one's below. So on f of x, we're now at negative 4. And g of x, we're at negative 1. How are we doing with locating these so far? Okay. We're going to keep going. At 0, f of x is at negative 6. And g of x is at negative 2. Do you guys notice a pattern at all in what's happening with g of x? It's going down by what? 1. Okay, so the slope of this line is negative 1. Sorry, positive 1. So we can just go ahead and fill those in. Let's just keep going with f of x one more time. So at x equals negative 1, we're at negative 6. What do we know about parabolas? They're symmetrical. So basically, if we follow the pattern here, we went 6, 0, negative 4, negative 6, negative 6. Next one will be at negative 4. So we're working our way back up. What's the next point going to be? 0. Good. And then 6. Awesome. So now that we've figured out what the y-coordinates of f of x and g of x are, we can complete the last section here, which is dividing f of x divided by g of x. So if you want to rewrite it in this notation, feel free. F of x divided by g of x. And we're just taking these two numbers and dividing. So for when x is 4, we'd go 14 divided by 2 is 7. When x is 3, we're going to go 6 divided by 1, we get 6. Okay, when x is 2, we get 0 divided by 0. What happens there?
Unreal.
Unreal. What's another way to describe that?
Miscellaneous.
Just doesn't exist. Okay, so DNE. And if you just put a little star here, it's because we can't divide by 0. Continuing down, okay, we're going to go still f of x divided by g of x, so negative 4 divided by negative 1, we get positive 4, negative 6 divided by negative 2, positive 3, and then we get, if we just keep dividing, 2, 1, 0, negative 1. You can see these are going down by 1. Chris, do you have a question? Sure? Okay. So if you look to part C, we'll talk about part B in a second, but if you look to part C, it says we're going to sketch these ordered pairs. So I'm just going to extend this table. and I'm going to write out the ordered pairs of x and f divided by g of x. Okay, so the ordered pair will be x and f divided by g of x. So in the first one we have the 0.47. Okay, x is 4, our new y value is 7. Then 3, 6. Will this point exist? No, we'll talk about that in a sec. Okay, moving on, we got 1, 4, 0, 3, negative 1, 2. Is anyone lost on where I'm getting these numbers? It's the x coordinate, and then f divided by g of x. So we're taking all these values and putting them as an ordered pair. So negative 2, positive 1. Okay, and then negative 3, 0. And negative 4, negative 1. So we didn't have to list them, but it's just a little bit easier when we go to draw the graph. So once you've copied down those ordered pairs, we'll just plot these points. So 4, 7. 3, 6. 1, 4. 0, 3. Negative 1, 2. And you can kind of see the trend. It's going down by slope 1. And we can see the trend of the points. It's going to create a straight line. So you can draw a line through these. And we're going to label this f divided by g of x. It's the quotient of functions f and g. So what about when x was 2? That doesn't exist, so can I have a straight line there? No, what we're actually going to do is we're going to put a hole where x is equal to 2. So line up where x is 2, go up to the graph, and we're going to draw a hole. And if you have space on the side, I want you to put when x is equal to 2, we have a hole. Otherwise known as a point of discontinuity. And that's all because we can't divide by 0. That point does not exist, so we have a hole in the graph. The point of discontinuity is something that's going to come up in later units, but for now it's just going to be a brief introduction. When we get into rational functions later on, we're going to deal with that. Okay, so for part B, explain why the domain of f divided by g of x is not any real number. So if we take a look at this graph that we just plotted here, why would the domain not be x is an element of all real numbers? Good. We can't have x equals 2, therefore the domain is different. So let's just record what the domain would be. And that would be part B in your notes. Just make sure you record that there. Okay, we'd say that we're talking about the x values, and all you have to do is say that x cannot equal 2, and all the other numbers will be real. Okay, so x can equal 2, and of the rest of the graph, it will be real numbers. So that's your domain. So did everyone have a chance to copy down the table of values and the graph? They can move up. Okay, so for part D, they're now telling us that the parabola was actually x squared plus x minus 6, and g of x, the line, was x minus 2. We have to find the expression for f of x divided by g of x. and then we're going to talk about the restriction on the domain. So f of x divided by g of x. We're going to write out f of x, which is x squared plus x plus, or minus 6, divided by x minus 2. Now hopefully you guys can remember from grade 10 and 11, anything in the denominator has a restriction when you're talking about rational expressions. We have to figure out what value of x would create this binomial, or set this binomial equal to 0. So what value of x would make this 0? 2. So right away we can state our restriction right here. We call that a domain restriction. You can say x cannot equal 2. Because we can't divide by 0. So with rational expressions, basically we want to simplify them. They're saying write and simplify. So the first thing you want to do is write f of x divided by g of x. Then I would say state your NPV. Another word for NPV is your domain restriction. Step 3, factor if possible. And these can be interchangeable steps, 2 and 3. So why don't we do that, and then we'll talk about the next step after. Okay, so we're going to factor this trinomial into 2 binomials. X goes in the front of each. And we need 2 numbers that will multiply to -6 and add to 1. So positive 3 and negative 2. Slide those into each binomial. And any guesses what step 4 is going to be?
Chop suey.
Chop suey. Cancel them out. So any common binomials that you can see, we're going to cancel out.
It's like actual terms. Oh, really? That's food, isn't it? That is food. It's like a nation dish.
And if there aren't common binomials, sometimes there's common terms. Okay, so chop suey, what are we left with?
X plus 3.
X plus 3. That's our final answer with the domain restriction of x cannot equal 2. How are we so far? Okay. For the next part, we have to evaluate x divided by g of -6. So instead of x here, what do we have? -6. So do you guys think you would go back to this step and put f of -6 divided by g of -6? Could you do it though? Yeah. But we've actually already simplified it to a much easier form, x plus 3. So we're just going to sub -6 into the x right here. -6 plus 3. Okay, so our answer is -3. It's a much easier form. Now, what if you weren't asked to simplify this at all? You were just asked to evaluate this given the 2 functions. Would you spend that extra time on a test to write it in this form, factor, simplify, and then sub in the -6? Or would you just go right into the original form? Okay, so try and be efficient on your test. Make sure you're understanding what it's asking. Okay, moving on. On the next page at the top, it just talks about that point of discontinuity, which we've already discussed, so we can skip over that.
Two mess backwards. All this.
Okay, so again, we're going to have an f function and a g function. Here in the first part, f of x is given as 2x plus 5. G of x is x plus 5. So you just have to write f of x divided by g of x. And then also include any restrictions. So if it's easier to look at, girls, we're going to write f of x divided by g of x. And then just replace f of x with 2x plus 5. And g of x with x plus 5. Okay, so we've done step 1. Step 2, it's already factored, so we can write our MPV, or a restriction. X cannot equal -5. Then take a look, can we factor? Okay, can we take anything out of the numerator or denominator? No, so we're done. Moving on to B, pretty much the same thing. We're going to write it as f of x over g of x. This time f of x is x squared minus 2x minus 35 divided by g of x, which is x minus 7. We have a trinomial in the numerator, so yes, we should be able to factor. So let's go ahead and do that. We need two numbers that multiply to -35 and add to -2. Okay, so I'm hearing 7 and 5 right away. That makes 35, but we got to figure out signs. Okay, if we're adding to a -2, we need -7 and +5. Which is ideal, because check out our denominator. It's x minus 7. So soon enough we're going to be canceling out those terms. But before we cancel out, what should we do? Good, we're going to state our non-permissible values or our domain restrictions. And in this case, x cannot equal +7. Once we've stated that, we can cancel out the common binomials. And we're left with x plus 5. So as you guys can see in the notes, I'm making my answers super obvious. On quizzes or tests, if you guys could make sure you're circling your final answers as well, just so it's a little bit easier for me. Hey, why don't you guys take a few minutes and try letter C? You can work together on that one.